All right. Good morning, John.
Hey, good morning, Ryan.
All right. Well, we're here. Ryan McCall, CEO here at NEQ, and with me is Jean Bernier, our founder and chief product officer. This is our first session of a coffee with Jean and Ryan. I've got mine here with my little state of Michigan mug. And yeah, I welcome everyone or anyone who possibly joined. But today, John and I are just going to have a chat about AI agents, what they are, how they understand, think, remember, respond. Um, just a not overly technical, hopefully informal, hopefully interesting conversation between the two of us. But again, so CEO here. I'm sitting here in the Chicago suburbs, and yeah, in my home office. And John, maybe tell everyone a little bit about yourself. You're the technical genius behind this. I'm just the dude asking questions. So I think letting people know what you're up to in Bogota and how and why you are an expert in AI, so they at least feel a little bit better that what they're hearing is in fact fact.
Thanks, Ryan. Happy to share with you and with all the people connected about AI. An interesting topic today. I'm in Bogota, beautiful weather and day we have here today. And something about me, 24 years working and researching about AI. So very interesting. I like how AI is evolving today. I also like quantum computing, neuromorphic computing, so more geek. And well, happy to start sharing here with all the positive vibes about this AI agents, and all the interesting developments that we have as humankind.
Awesome. Thanks, Sean. And then just for anyone who is attending, if you do have a question, just please put it in the chat for us. We will be sure to answer any questions that do pop up at the end before we wrap up. So, with that said, let's get started. So, I think, John, the best way to start here, and again, for everyone listening, we want this to be a nice blend of, both informative, but not, too, dumbed down or high level. So there's gonna be a little bit of technical thrown in there. So at the start, if you're thinking this is just too simplistic, bear with us. We'll get in a little bit more of the details as we go on. But at the start, how about we just start with John? Like, what is an AI agent, and also specifically, how is it different than just a GPT? Because I think that's really helpful, and a lot of people really don't understand that difference.
That is the $1 million question. uh, GPT, it is an interesting topic. It is a concept that we have today. Many people talk about GPT, but we need to say, and let's start with the difference. GPT, it is a technique that OpenAI used to create large language models and create those AI models and systems they have. So GPT is a transformer technique, but there is also another layer, and let's say that Chat GPT. This is a product, and there are many other layers, or better models that will understand natural language and have the same function and the large language model. It is OpenAI, Microsoft, Google, AWS, and many others. In the app layer, it is the chat applications, ChatGPT, Gemini, Anthropic, and many others. And they are large language models with superpowers. So they can answer questions, they can connect to other tools, bring solutions, research on internet, and the model on behind that is training with different techniques help us to understand better all that information. That is the thing. But the AI agents, it is the next level. And we can find AI agents today in many applications and can support us in many needs and requests that we have. The AI agents has also a large language model. Could be the OpenAI, again, Microsoft, Google, and many other companies, large language models. In fact, an AI agent and let's say a private or external AI agent can manage multiple large language model, not only the open AI. When you use ChatGPT, it is something that you could imagine. You have access only to the open AI models. Same with Google, same with Microsoft. But let's say if you are using the NEQ AI agents, you can have access OpenAI and other large language model on behind to solve the needs. That means that are different techniques, trainings, large language models, knowledge bases on behind. But the other power of the large language model, it is the memory, and they can remember, and we will talk about this after. But also it is the connection and interaction with other tools and other agents. So imagine other tools. Let's go with the most simple: your email, your calendar, your files or your cloud folder, and more complex tools, maybe the CRM of the company. You have a storage like SharePoint, Google Files, and other solutions. Or even you could have more complex systems that you can have tracking systems. If you are an e-commerce or retail company, you could have all the logistics applications on behind connected to the AI agent. You can have a specific knowledge bases. And the interesting thing it is the agent or the AI agent can use your request and connect the different tools and give to you a better solution and interact all the tools. So, for example, you can say something like, "I need to send a specific delivery to a specific client," and the AI agent can query your email or your inbox, understand what your client is requesting, and using that information can query the CRM and find the specific address with all the location details, and can go to the logistic application and create the deliverable and all the information in the process. And was for the human side, automatically, almost magical process, but on behind the AI makes many queries, many processings, and interact and create that flow and chain for the user.
Awesome. No, that's really fascinating, John. So at the highest level, or the most I guess concise level, right? The difference being where a Chat GPT or the like, right, or a chat function connected to a large language model that then has access to uh, very powerful but more generic tools, right? Like say a web browsing or a search engine, right? And then an AI agent then connects to or can connect to more than one large language model, but is generally more uh, customized in terms of its functionality, connecting to more specific tools and trained to do more specific tasks rather than the more general tasks that say a chat GPT does. Is that about right in terms of a high level?
Yes, totally.
Cool. All right. Well, at least if you got me to understand it, then hopefully everyone else can. So from there, I think it's probably good to learn just more about AI agents and how they function. So it, first and foremost, like, can you talk about so the title of this is how AI agents understand, think, remember, and respond. So let's start to work through those. So like, how about we talk about how AI agents just first understand what you're talking to them about, what you're asking them to help you do.
Great. The AI agents can understand the request thanks to the large language model. That the large language model, it is an AI system that understand the natural language, how we speak as human, and understand language, the different idioms, also can understand the logic and the needs of the users and the different ways that everybody speaks and explain everything. So the AI agents, thanks to the large language model, can understand and convert that, let's say, to a AI understanding. That AI understanding, it is they identify entities, intentions, and connect that information to build that request. when I say entities, for example, if you say in the last case, I need to create a deliverable for customer A to send to Chicago. Uh, the entities, it is customer A, also another entity, it is Chicago. The product that you want to send, it is another entity. But the intentions that the large language model can build there, it is, well, I want to send the product, that is that entity, to the specific customer, that is another entity. So it connects that intention, that logistic action to send through that process. So that is how the large language model help us or help the AI agent to identify. And that intentions can be connected to the tools, for example. So it says, I need information about the customer. So let's try to use the CRM tool, the inbox tool, to get more information and what the large language model can read them. So that is the first part, how they understand.
That's great. And I think the best part about that, at least to me, is what it does for chat GPTs and AI agents. And that means what I'm getting at is that they're inherently baked in to be multi-global, right? Multicultural and global, right? You know, a great advantage for anyone creating an agent is that by almost inherently they're multilingual, can generally understand dozens or hundreds of languages just from the start because of the LLMs that they built on. I think that's really cool from just a tool perspective, but also from a global perspective.
Yes, it is remove barriers. It is about real democratization. So a company like us that we speak English and Spanish. Now with the agents and that power, we can speak in French, in Italian, and many other languages, and understand also cultures, not only about the language. So it is amazing.
Very cool. Great. So now we know how AI agents understand us when we ask them things. Um, how about we talk about first then how they think, and then from there how they think, and then how they generate the response.
Great. That think question, that think word, it is something interesting to analyze today in the AI world, because AI, it is artificial intelligence, and intelligence means that we can learn, we can fail, we can make mistakes, and we can find better ways to solve. And that could be the most close concept to the thing in the AI. I know that we have many tools today, and you write something and you can use reasoning models, and they show to you thinking word, and they say the model is thinking, and you see a kind of trace of all the things that the model is trying to analyze and thinking. But those steps that you can see as thinking process today, it is just how the AI agent that is on behind is making different requests, different approaches or calls to the large language model in a combination with the specific tools that has. Those tools could be, let's say, actionable tools, the inbox, your CRM, could be knowledge based tools also. That means more documents, more knowledge, specific information to make close or more segmented the response. So that means that could focus better and could have other kind of tools, other agents, other actions that could help to create that answer. So imagine the thinking process of the AI as a chain of many prompts that start with a user request, but the main model, we can say that, or the main agent doesn't has the responsibility to solve the request, has the responsibility to create all a chain of other prompts and make microsegmentation of the problem and split in different stages and trying to solve in a logical order using all the resources that has. the knowledge and the context window of the large language model, all the kind of tools that could has, and also the memory that is other thing that we could have. And in the last step of this logic chain, the large language model again has all the information and creates like a summarization to bring that answer to the user. Again, that answer is trying to create it in the natural language that we can understand. So you can create your prompt or your request in English, but you can say, I need the answer in Spanish. And the logical process in the last steps for sure will be make a translation and give the answer to you. So that is the thinking process.
That's great. And I think what's interesting about that is, and this is extremely simplistic, but relevant, right? The tool being an agent is only as good as its resources behind it, right? So whatever LLM it's calling, whatever tools it's connected to, and how it's been prompted to respond, which then gets into the response, right? Because one of the things that I really like about tools like ChatGPT is you can condition it to respond in very specific ways for any question you ask it, right? And I think agents are very similar, whereas it's usually the person designing the agent that conditions it how to respond rather than the individual user. But at the same time, we know with like the agent's NEQ, you do have some measurement of control there. You can tell the agent to respond in Spanish or French or whatever language you choose, even if you're asking it a question in English. So I think that's very natural. Then that gets into you know we know how it understands, we know how it thinks, and as you said, micro segments into more prompts and accessing all of its resources that it has available to it. And then how does that summarize everything from those micro prompts into an actual response?
Yes, yes. That is the full process, let's say, in a landscape and a general vision. Something interesting it is we speak in our language, but AI understand that and converts to probabilistic and matrix language. So it is linear algebra on behind. It is millions of probabilistic calculus on behind to build that response. And that is how that AI, let's say, magical process happens on behind.
Very interesting. So I think getting into then the response, right? So the AI agent collects everything and then responds basically how it's been prompted to respond. But what's more important is that it remembers, it has memory, which causes it to then be able to recall and then hopefully learn. So I think that's to me one of the most fascinating things about these. It's and then really one of the biggest differentiators between just a chatbot, if you will, is the ability to have memory, learn, remember, and respond differently the next time if it learned differently. So let's talk about that. Like how does an agent remember? How does it learn from that memory?
I love how you made the question. It is how AI agents can remember because it is the architecture of the AI agent that has the memory. The large language model per se cannot remember. Large language model, it is only a huge database and system to create that answers, but needs a context and information and a prompt. And the memory is part of that input that the large language model receives to create the answer. So, in simple terms, you can imagine the memory of an agent as a message exchange between different systems. So, it is a database, or imagine a spreadsheet. And you have in many rows two simple columns, one that says it is something from the user or is something from the AI, that message. And in your column B, you have the information, whatever the user sent as prompt, and all the information that the agent solves that answer. and the memory is built on that way. So you could have many rows. Imagine something like this: a conversation with GPT or other agent, or chat GPT or other agent, of 10 interactions. That means I ask as user and the agent replies something to me. 10 interactions could be at least 20 messages in that memory table. So that memory table with the 20 message comes to the context window of the prompt when the user adds or makes the next question, the 11th question. And you have all that in background, and the agent use into the context window with the large language model and say, the user now is asking this. This is all the previous conversation that we have from the database, and create that solution. And that could be used for the large language model to decide which tools, if you need to call again a tool, if there is a specific topic behind that, or in the past that you have in that conversation. So you can say something simple like, I like the color blue. Please remember that my favorite color is blue. And 10 questions before, after, you can say, I want to create a logo for my company. Please use my favorite colors. So the large language model decide to not ask again to you which is your favorite color, because it knows that has blue in one message, just because it is in that table. But the memory, it is something critical for agents today. Just imagine that is an exponential growth how many messages you need to remember in that conversation. It is different and is very similar to have a conversation with other person. For example, imagine a relationship of 1 year with a person. It is more simple to you to remember what you chat with that person last week. Let's say that is 5 messages ago, rather than remember exactly what you chat 12 months ago. It could take more time, more effort to you to try to remember that things. Same happen with the AI agent. So more memory, it is more data to process. It means more tokens that you use in the context window, and well, also could create distraction in the conversation, in the answer. And something interesting it is, you need to balance the memory. Too much memory could bias the model, could create hallucinations. Lower or a short memory could create the same effect. And it is not a magic formula for this. It is depends on the agent that you have, the kind of conversation, how you are building that to have that kind of memory.
So, trying to simplify this for myself, and maybe for a couple of people out there, John, but this almost is just really analogous to short-term versus long-term memory, or memory versus storage in a PC, right? And what I'm getting at is, you know, for memory on an agent, or short-term memory, right? You can only remember so many things at once before you start to get confused or forget. It's like studying for a test. If you cram for a test, you're going to retain just enough to hang out in your short-term memory banks that you can hopefully just spit it back out on a paper. Versus training an agent or an LLM or your long-term memory, where you actually learn and then you can recall that at any point in time. Is that kind of what we're talking about here?
Yes, yes. That is that specific situation, and you need to use memory based on the specific case that you need to solve. Let me show something. Let's talk about is clinical history from a patient. You need the full context, the full memory and information. So it is a good option to have all the data to create the next answer, or the next reply from the agent. Let's talk in another different scenario that maybe you don't need to have all the memory. a jokes agent. Uh, Maybe the last five, it is enough to have a good conversation here. It is totally different case. Let's talk about marketing agent, or something that create content. Maybe talking about trends of the last year. It is not trends, it is not new, it is not important today. So the memory also could have a scope in time no more than 1 month in trends and data to understand. So that is the magic thing here. You need to learn and understand. And that is interesting because there are criteria, there are KPIs and metrics to understand when the memory is starting to degrade the conversation and the answers from the agent. So using that data, the same AI could be data driven and understand how much memory it is the best option.
Very cool. Yeah, I love that. It's I mean, I don't want to say excuse me. It's as much of an art as a science, but I mean, self-admittedly, you said that there's no equation for how much memory or how little memory it should have. It's all application dependent, and I'm sure just the coding behind the agent as a plays a large factor in it as well. I mean, it's very easy to write, um, you know, elegant code, so an elegantly designed agent versus one that's overly designed and has way too many paths to deal with, right? So, anyways, great stuff. Well, we're running out of time. We don't really have too many questions, so I think that maybe we'll wrap it up here today, Jean. Really, thank you very much for the technical know-how. Hopefully, a couple people learned something today. If anyone is interested, please scan the QR code, can take you to our website and check out what AnyQ does, or you can just check out anyq.ai. But again, thank you for attending our first coffee with Jean and Ryan. Hopefully, we do more of these because they're fun, and I always enjoy sitting here having a conversation with Jean. So, thank you again. I'm Ryan here, CEO at AnyQ, and this is Jean, our Chief Product Officer and founder. And thanks for joining us today.
Thanks to everybody. Thanks, Ryan. I enjoy a coffee with you.
As always.